Hi everyone, welcome back to Beginning Algebra. Today we're in section 3.2 and we're going to start graphing linear equations into variables. So we're going to look at a few different things here. First, I'm going to show you how to graph linear equations by plotting ordered pairs. And then I'm going to show you how to find the intercepts, and we will graph lines using the intercepts. I'm also going to show you how to graph linear equations that are in the form ax plus by equals 0, because when the right side is 0, we have to handle things just a little bit differently. And then we'll look at how to graph equations that are in the form y equals b or x equals a. Now remember from section 3.1 that a linear equation in two variables has an infinite number of solutions, and those solutions are ordered pairs. And we can see the pattern that's formed by those solutions if we plot some of the solutions on the coordinate system. Different types of equations will make different patterns. Now, we did this last time. Remember, to generate the solution of an equation in two variables, you're going to choose any convenient value that you like for either x or y, and then use the equation to calculate the other value. The resulting ordered pair will be a solution, and you can plot that solution. Now, very often, it's convenient to generate one solution by plugging in x equals 0 and generate a second solution by plugging in y equals 0, because 0 is just an easy number to plug in. And the graph of any linear equation in two variables is going to be a straight line. In fact, that's why they are called linear equations. You see the word line inside the word linear. So these are called linear because their graphs do make a straight line. So when we look at a graph of a linear equation, every point on the line represents a solution of the equation. And the other way around, every solution of the equation will be a point on the line. So let's practice graphing here using the equation x minus y equals negative 3. And you can see that over here I've got us an xy table. So we just want to pick out some convenient values to plug in for either x or y. I'm going to choose to plug in 0 for x, because plugging in 0 is always easy. And for my second point, I will choose to plug in 0 for y. And then for us, just for a double check, we're going to plug in any third value and generate a third solution. So you can use any x or y that's convenient for you. I'm just going to choose x equals 1 here. So in a minute we'll plug that in and generate the y value that goes with it. Let's start with x equals 0. So if our equation is x minus y equals negative 3, and we plug 0 in the place of x, then we're going to get 0 minus y equals negative 3. And of course, the left side will simplify to just negative y. So now we have negative y equals negative 3. Multiply both sides by negative 1, and we know that y will equal positive 3. You know, that just makes sense. If negative y is negative 3, then positive y would have to be positive 3. So now this gives us the point 0, 3, because our x value is 0 and our y is 3. And I'm just going to go ahead and put a 3 here as well. And now let's plug in 0 for y. So taking our same equation, we'll plug in 0 for y, so that will give us x minus 0 equals negative 3. Okay, the left side just simplifies to x, so now we have x equals negative 3. And that's going to give us the ordered pair negative 3, 0. Remember, when you write your ordered pair, the x value has to come first. And so I'm going to put negative 3 here in my table. So honestly, we could graph the line just using these 2 points, but for us in this section, we're going to go ahead and generate a third solution just to make sure that all 3 points are on the same line, and that will just help us know that we didn't make any careless mistakes. So this is an x value I've got here. I'm going to plug 1 in place of the x. So that's going to give us 1 minus y equals negative 3. And now we will solve for y. So I'm going to say, let's subtract 1 from both sides. That will give us negative y equals negative 4. And if negative y equals negative 4, that means positive y equals positive 4. And so our ordered pair here is 1, 4, and I will put a 4 here just to fill in my table. And now we should be able to plot these 3 points and see that the ordered pairs form a straight line. So 0, 3 would be starting from the origin. Don't go left or right any, or left or right 0, and then up 3. So we'll put a dot there. Then we have negative 3, 0, so that's going to be left 3, and we'll put a dot there. And then 1, 4. So starting from the origin, we'll go right 1 and up 4, and we'll put a dot there. And you see how those form a straight line? So when you see that straight line, you know that you've done everything correctly, and we can just graph our line now. And every point on this line is a solution of the equation that we started with, but we didn't have to calculate all of them. We only had to calculate 2 and a third one as a check. Here is another equation. This is example 2, and we'll do it the same way, but this equation is maybe just a little bit more complicated. But it's always a good idea, remember, to plug in 0 for x, and then plug in 0 for y, and then just choose a third point that seems convenient. So I will choose x equals 2 for my third point. Okay, so let's start with x equals 0 and plug that into our equation and see what we get for y. So we'll get 3 times 0 minus 4 times y equals 12. Of course, 3 times 0 is 0, so the left side simplifies to negative 4y, and that's equal to 12. And now we'll isolate the y, so we'll divide both sides by negative 4. That's going to give us y equals negative 3. So our ordered pair here is 0, negative 3. And I'm going to also copy the negative 3 here just so I can have my table filled in. Now let's plug in 0 for y. So we'll take our same equation, but we'll put 0 in the place of y. So we'll have 3x minus 4 times 0 equals 12. Of course, 4 times 0 is 0, so that term's going to disappear, and that will just leave us with 3x equals 12. Now divide both sides by 3 to isolate the x. That gives us x equals 12 divided by 3, which is 4. So that point is 4, 0. Remember, the x comes first, then the y. So I'll have a 4 here. And then for our third point, let's plug 2 in for x. So we'll have 3 times 2 minus 4 times y equals 12. Okay, 3 times 2 is 6. And that's going to give us 6 minus 4y equals 12. And now we want to isolate the y. So let's subtract 6 from both sides. That will give us negative 4y equals 12 minus 6, which is 6. Now divide both sides by negative 4, and we'll have y equals 6 divided by negative 4. Now, this won't make a whole number, but it will reduce. Positive divided by negative is negative, and 6 and 4 can both be divided by 2. So we end up with y equals negative 3 over 2. Now, if you have an improper fraction, when you go to graph it, it's not always easy to know where that point should go. So I recommend changing this value into mixed number form just so you can find it on your coordinate system. So we know that negative 3 over 2 would be equivalent to negative 1.5 because 2 goes into 3 once with 1 left over. So our ordered pair here is 2, negative 1.5. And I'll put my negative 1.5 here as well. Okay, so now let's graph our 3 points. 0, negative 3 is going to be straight down from the origin, 3 steps. 4, 0 is going to be right from the origin. And then 2, negative 1.5, we would go right 2, down 1.5, and put a dot there. And you can see those form a pretty straight line. And so there is the graph of our line. Now I have a similar one here for you to try. So pause the video for just a minute, try this one on your own and see how it goes. And now I'm going to go through this one with you. So remember, we always choose our own x's and y's. It's a good idea to let x equal 0 and then let y equal 0 and then just choose any other convenient point for either x or y, whichever you prefer. And I'm going to choose to let x equal 2 again. So now plugging 0 in for the x, we'll have 4 times 0 minus 2 times y equals negative 8. 4 times 0 is 0. That gives us negative 2y equals negative 8. Now divide both sides by negative 2. The negative 2's will cancel out, and that's going to leave us with y equals negative 8 divided by negative 2, which is positive 4. So now our ordered pair here is 0, 4. And I put the 4 here. Let's go ahead and plug in y equals 0. So that would give us 4 times x minus 2 times 0 equals negative 8. 2 times 0 is 0. So that leaves us with 4x equals negative 8. And we'll divide both sides by 4. So that leaves us with x equals negative 2. So our ordered pair here is negative 2, 0. So the negative 2 goes here. And now let's plug in x equals 2. So that will give us 4 times 2 minus 2 times y equals negative 8. So 4 times 2 is 8. That gives us 8 minus 2y equals negative 8. Now we want to isolate the y. So we'll subtract 8 from both sides. That's going to give us negative 2y equals negative 16 on the right. Remember, negative 8 plus negative 8 would be negative 16. Now divide both sides by negative 2, and we get y equals negative 16 divided by negative 2, which is positive 8. So our ordered pair here is 2, 8. And I'll put the 8 here in my table. Now we can just plot our 3 points. So 0, 4 would be starting from the origin, go up 4. Negative 2, 0 would be starting from the origin, go left 2. And 2, 8 would be starting from the origin, go right 2 and up 8. And now we'll just draw the straight line that goes through all 3 of those points. And there's your graph. Now let's talk about intercepts. An intercept is just the point where the line crosses an axis. The x-intercept is where the line crosses the x-axis. So if you look at the diagram here, I've got a line, and this point where it crosses the x-axis, that is the x-intercept. And the y-intercept is where the line crosses the y-axis. So back to the diagram, this point where the line crosses the y-axis is the y-intercept. Okay, now notice that because the x-intercept is on the x-axis, the y-coordinate will always be 0 for the x-intercept. So it will always be some number, 0. And because the y-intercept is on the y-axis, its x-coordinate will always be 0. So the point here will always be 0, y. Now, because the x-intercept has a y-coordinate of 0, if you want to find the x-intercept, all you have to do is plug in 0 for y. And because the y-intercept has an x-coordinate of 0, if you want to find the y-intercept, all you have to do is plug in 0 for x. So, one more time, to find the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. So let's practice now graphing an equation that's in standard form by finding the intercepts. So notice that I don't even have us an xy table over here. All we're going to do is calculate intercepts. So remember, to calculate the x-intercept, we plug in 0 for y. That would give us 2x plus 0 equals 4. Of course, if this term is 0, it just disappears. That gives us 2x equals 4, and we'll divide both sides by 2. And that will give us x equals 2 for our x-intercept. So all we have to do to plot this point, we know it's on the x-axis, so all we have to do is come to the right 2 spaces and put our dot. Of course, the point here is 2, 0. And then for the y-intercept, we just plug in 0 for x. So that would give us 2 times 0 plus y equals 4. 2 times 0 is 0. So now we can see that y equals 4, and that will be our y-intercept. So we'll just go up the y-axis and put our dot at the 4. And now the straight line that connects these two dots is the graph we're looking for. If you wanted to be extra sure that your graph is correct, you could pick one more x value and plug that in and calculate the y value and just make sure that that point falls on your line. Now here's one for you to practice with. So our equation this time is 5x plus 2y equals 10. See if you can find the intercepts on your own and graph the line by yourself. Okay, now I'm going to go through this with you. So let me show you how I do it when I'm working on my own paper. If I start with the equation 5x plus 2y equals 10, I know that I need to plug in 0 for y, but I don't actually write it down that way. I just actually cover up this term with my hand or my finger somehow so that all I can see is the x term and the constant. So if y is 0, then what's going to actually happen is that y term is going to disappear, and it will just leave you 5x equals 10. And now you can divide both sides by 5, and you'll see that x equals 2. So that's your x-intercept. You can just come over here and plot that point. And let's do the same thing for the y-intercept. So for the y-intercept, we want to let x equal 0. That means we'd just cover up this x term. So I'm just going to erase it. And that leaves us 2y equals 10. Divide both sides by 2, and we get y equals 5. And so we'll plot that point. And the graph we're looking for is the line that connects these 2 points. Now let's look at example 4. Here is an equation that is not in standard form, but it is still a linear equation. So we can still find the x-intercept and the y-intercept by plugging 0 in for the appropriate variable. For the x-intercept, remember we want to let y equal 0. So I'm just going to copy the equation over, but instead of y equals, I'll put 0 equals negative 3/2 x plus 3. Okay, now to find the x-intercept, we actually need to solve this equation for x. So let's subtract 3 from both sides. That will give us negative 3 equals negative 3/2 x. And now, do you remember how to eliminate a fractional coefficient? Think back to section 2.2 when we learned how to eliminate coefficients that are in a fraction form. Remember what we did was to multiply both sides by the reciprocal of this coefficient. So the reciprocal of negative 3 over 2 is negative 2 over 3. Remember, a number's reciprocal has the same sign as the number, and so we're multiplying both sides by negative 2 over 3. All right, now on the left side, the negative 3 divided by the positive 3 will give you negative 1. This negative 1 times this negative 2 will make positive 2. On the right side, multiplying negative 3 over 2 times negative 2 over 3 would make positive 6 over 6, which is 1. So you could say that multiplying these two fractions together makes them cancel out, and the right side will just be x. So now we see that our x-intercept is 2, so I'll plot that point. And now let's find the y-intercept. So we'll plug in 0 for x. That's going to give us y equals negative 3/2 times 0 plus 3. So of course here 0 times negative 3/2 is 0, and we see that the y-intercept is 3. So I'll put my dot here on the y-axis. And now we can just draw the straight line that goes through those 2 points. And there's our graph. Now here is a similar equation for you to try to graph on your own. This one is y equals 2/3 x minus 2. So you can see this one is not in standard form either, just like the last one. So pause the video and see if you can, on your own, find the x-intercept and the y-intercept and draw the graph. Okay, now that you've had a chance to try it on your own, I'm going to go through it with you. So first let's find the x-intercept. To find the x-intercept, we would want to plug in 0 for y. So that's going to give us 0 equals 2/3 x minus 2. Okay, to solve this for x, we'll need to add 2 to both sides. That's going to give us 2 equals 2/3 times x. And now we want to isolate the x. So we want to eliminate this 2/3 coefficient. And the way to eliminate a fractional coefficient is to multiply both sides by its reciprocal. So I'm going to multiply the right side by 3/2 and also the left side. Now on the left side you can see that we have a 2 in the top and a 2 in the denominator. So 2 divided by 2 is 1, and therefore those 2's will cancel each other out, and we'll have 3 for the left side. On the right side, 2/3 times 3/2 would be 6/6, which of course simplifies to 1. So on the right side, we just get 1x. So I'll write that as just x. And now we see that our x-intercept is 3. So let's come over here and put a dot on the x-axis at 3. And now let's find the y-intercept. So we'll plug in 0 for x, and that will give us y equals 2/3 times 0 minus 2. So 2/3 times 0 is 0, and we see that the y-intercept is -2. So I'll come to the y-axis and put a dot at -2, and then we'll draw the line that goes through those 2 points. Notice that when the equation is in this form where it's solved for y, the y-intercept is very easy to get, because when you plug in 0 for x, this x term will always become 0, and so the y-intercept is always the constant that you see here. And again, this is happening because the equation is solved for y. So actually, even though this is not standard form, it is a form that's very easy to work with. Now let's talk about what happens when you have an equation that's in standard form, but the constant on the right side is 0. If the right side of a linear equation in standard form is 0, then the x-intercept and the y-intercept will both be at the origin. And that means that knowing the 2 intercepts is not enough information to graph the line, because in order to draw the graph of a line, you need to know 2 points. But if our intercepts are both at the origin, we really only have 1 point. So finding another point is pretty easy. All you have to do is plug in any convenient value for x or y, totally your choice, and then solve for the other variable, and that will give you an ordered pair that you can graph and use to draw your line. So let's try here with example 5. This says graph x minus 3y equals 0. Now I told you on the last slide that if the equation is in standard form and the right side is 0, that both the x-intercept and the y-intercept will be at the origin. But let's just find the x-intercept and the y-intercept ourselves, and you'll see what I'm talking about. So to find the x-intercept, remember we plug in 0 for y. So if we take our equation and we plug in 0 for y, we know this entire term is going to go to 0. So we see that the x-intercept is at 0. We can go ahead and put our point on the origin. And now if we do the y-intercept, we'll plug in 0 for x. So if we take our equation and plug in 0 for x, this term will disappear, and that leaves us the equation -3y equals 0. Divide both sides by -3, and of course that gives us y equals 0 divided by -3, which is still just 0. And so now we see that the y-intercept is also at the origin. So you can see that we currently do not have enough information to draw the graph of this line. We need one more point. So let's just choose any convenient value for either x or y. I'm going to choose x equals 3, and you'll see why I chose that number in just a minute. So let's plug in our 3. We'll have 3 minus 3 times y equals 0. So to solve this, now you have a choice. You could subtract 3 from both sides, and that would be fine. Here I notice that my y term is negative, so I'm going to add 3y to both sides, just so I can have a positive variable term. That's going to give us 3 equals 3y, and now we'll divide both sides by 3, and we'll see 3 divided by 3 is 1, so y is going to equal 1. Now I told you just a minute ago that I chose x equals 3 for a reason, and that reason is that it was convenient for me. Suppose I had let x equal 1, then I would have gotten 1 minus 3y equals 0. Add 3y to both sides, and I would have had 1 equals 3y, and divide both sides by 3, and I would have gotten y equals 1/3. And then I would have had to graph the point 1, 1/3. If you don't want to have to graph a coordinate that is a fraction, then what you want to do is just choose an x value that will give you a y value that is an integer. In other words, a y value that doesn't have a fraction part. For us, that turned out to be x equals 3. I'm not telling you that you need to figure out in advance what's going to give you a whole number. On the contrary, I'm telling you that if you do a calculation and you don't like the point you get, we'll just pick a different x value and do it again. But there's nothing wrong with this point. I just didn't want us to have to graph a fraction. So now we're going to graph the point 3, 1. So I'll come over here, and from the origin, I'll go right 3 and up 1, and there's our second point. And the graph is the line that goes through those 2 points. Now here is a practice problem that you can try on your own that's very similar to the last example we did together. This is another equation that's in standard form, and you can see that the right side equals 0. So pause the video and try this one by yourself. Now I'm going to go through the solution with you. So remember that if your equation is in standard form and the right side equals 0, that tells us that the x-intercept and the y-intercept are both at the origin. You really don't have to go through the calculation to show that they're both at the origin. This is just a fact that we can accept. So now that we know that we have a point on the line that goes through the origin, we need to find a second point. So remember we said that to find that second point, you can just let x or y be any convenient value. So what I'm going to do is just let x equal 1 and see what happens. So if x is 1, we'll have 2 times 1 minus y equals 0. And now we need to isolate the y. And since the y is negative, I think the shortest, quickest way to do that is just to add y to both sides. So that will give us on the left 2 times 1 minus y plus y, which is just going to be 2. And then on the right, 0 plus y is y. So now we can see that the point 1, 2 is going to be a point on our line. So let's go ahead and graph that. So from the origin, we go right 1 and up 2. There's our second point, and we can just draw the line that goes through those 2 points. And there's the graph we were looking for. Now let's look at equations that are in the form either y equals a number or x equals a number. So take a look at the equation y equals -4. If we try to put this in standard form, remember standard form means we have an x term and a y term on the left, and we have a constant term on the right. Well, we don't have an x term showing here, so that means the coefficient of the x term is 0. So this could be written as 0x plus y equals -4. When you look at the equation this way, you can see that because of the 0 coefficient, no matter what we plug in for x, this term is always going to be 0. And so every number we plug in for x gives us the same y value. We'll always get y equals -4. So no matter what's plugged in for x, the y value will always be -4. And now look at the equation x equals 3. If we write this in standard form, we could write it as x plus 0y equals 3. In this case, you can see that no matter what we plug in for y, the y term is always going to be 0. And so no matter what we plug in for y, the x value will always be 3. So let's take the equation y equals -4 and let's make ourselves a little xy table. Okay, y equals -4 means that no matter what number we use for x, the y value will always be -4. So if we plug in 0 for x, y is -4. If we plug in 1 for x, y is negative 4. If we plug in 2 for x, y is negative 4. If you come over here and plot those 3 points, 0, negative 4 would be here, 1, negative 4 would be here, and you can see that those points are forming a horizontal line. So this line represents all the points whose y-coordinate is, guess what, negative 4. And let's look at x minus 3 equals 0. So of course if we take this equation and add 3 to both sides, we can see that x equals 3. So no matter what y is, x always equals 3. If we let y equal 0, x has to equal 3. If we let y equal 1, x has to equal 3. If we let y equal 2, x has to equal 3. So again, no matter what y is, x has to equal 3, and let's plot those points. 3, 0 would be here, 3, 1 would be here, and 3, 2 here. So you can see that these points are forming a vertical line. And this line represents the set of all points whose x value is 3. So let's try to sum this up. An equation of the form y equals b, where b is a real number, will always graph a horizontal line. Now notice that except for the x-axis itself, a horizontal line will have no x-intercept. Remember, an x-intercept is where the line crosses the x-axis. So since this line is horizontal, it runs parallel to the x-axis and it will never cross it. Therefore, it has no x-intercept. In fact, the x-axis is just the line that's given by the equation y equals 0. Think about it. If you look at the line that goes along the x-axis here, this is just the set of all points that have a y-coordinate of 0. And then if we have an equation of the form x equals a, where a is any real number, that will always graph a vertical line. And notice that except for the y-axis itself, a vertical line cannot have a y-intercept because a vertical line runs parallel to the vertical axis, so it can never cross the y-axis, so it can't have a y-intercept. The y-axis is just the line that's given by the equation x equals 0, because if you think about it, every point on the y-axis has an x value of 0. Now I know there was a lot of new information in this section, but graphing lines is not hard. You just need a little practice to get used to it. You need to spend some time thinking about it, and it will start to come naturally to you. So a lot of people get stressed out about graphing. I hope that you won't, because it's really not that difficult once you've gotten used to it.